Hello, we are going to be starting Unit 5, which is division. Unit 5, Lesson 1's target is I can divide with whole numbers, and we will be doing it by dividing and by using estimation to check for reasonableness. Vocabulary that you should know and be able to use is dividend, which is the number right here, or the value of the whole that is being divided. The divisor, right here, the 8, is the number you are dividing by. It can represent groups you are taking out of the number or the number in each group. The quotient, which is the answer to a division problem, again can represent groups you are taking out or the number in each group. And you may have a remainder at the bottom. And that's the number left over when a divisor does not divide evenly into a dividend. And for now, if you have that remainder, you can just write a capital R next to the dividend and a period and then a 2. So represent your remainder as the whole number 2. Why does this all work this way? Well, the dividend divided by the divisor equals your quotient, and remainder is just like in multiplication. Your product divided by a factor equals another factor. These two are factors. 8 multiplied by 567 would be 4,536, and then when I add the remainder to it would be 4,538. So as you're working through this unit, become familiar and be able to use this vocabulary. So what do you remember about division with whole numbers? At this time, you would pause the video and just think back of what you remember. Okay, you should have unpaused now. And some things that you maybe remembered is when you get a remainder, it can't be greater than the number you're dividing by. You might remember that division is taking equal groups out or finding how many equal groups of something are in another number. If we have, so now let's take a look at some different methods of division. And we have this situation. An airplane travels the same distance every day. It travels 3,822 miles in a week. How far does the airplane travel each day? Anytime I have a word problem, I want to make sense of it with a model. Me, personally, I like to use bars to model problems. Here's where I wish I had my smartboard, but I would draw a bar and I know that 3,822 is my whole. So that's what my bar is worth. The whole bar is representing the 3,822. And you'll have to forgive my horrible writing, but using a keypad just doesn't work well for it. Now, in this case, it is traveling each day in a week. So that means it's traveling in 7 equal parts. So I have 2, 3, 1, 2, 3, 4, 5, 6, 7. I'm going to pretend they're equal parts, and I'm looking for how many are in each part. So when I'm dividing it into equal parts, I know it's division. Another thing that works, another model that works really well whenever a problem ends up being division or multiplication is the area model. I know the entire area is 3,822, and I know that I want it in 7 equal parts. All right, now place value, one method is place value sections. You may be familiar with this being called the area model of division. So I have 3,000. I'm just going to, and that's because it comes from the area model that I drew here. So thinking of that, what I want to do is take my 3,822 and put it into a rectangle. And dividing by 7, I'm going to take the place value of the 3,000s. Can't be divided into 7 equal groups. So I'm going to ungroup the 3,000 into hundreds by looking at the 3,800s. How many groups of 7 can I put 3,800s into? 38 into 7 equal groups. Well, I know that would be 5. So 3,800 would be 500 groups. And 5 multiplied by 7 is 35. So 500 multiplied by 7 is 3,500. And I don't have much room left because it's really hard to draw this way. But then what would be left would be 322. So now I would draw another rectangle for my hundreds. So this was my thousands actually turned into hundreds. These are my hundreds, which actually are going to be my tens. Oops, that's a 2. So again, there's no 7s. I can't take 300s and break them into 7 groups. So I'm going to take make it into these 300s into 30 tens, and I have 32 tens in 322. How many 7s in 32? There are 4. So if there are 4 7s in 32, there are 40 7s in 320. And 4 multiplied by 7 is 28. So 40 multiplied by 27 is 280. And all that should have been from our unit in multiplication. You should remember that. 322 subtract 80. Okay. Which I have a 2 left. And 30. Oh, I have 4 left. And I have 42 left. So now I'm going to make, well, I had 4 10s left and 2 1s. So now I'm going to make a box for my 1s, and I have 42 1s left. How many 7s go into 42? And that would be exactly 6 groups of 7. 6 groups of 7 are 42. And I have 0 left. Now, to combine my hundreds, tens, and ones, just like an expanded form, place value sections, I just add those together, and I have 546 as my quotient. So place value sections, like I said, you may remember it as calling the area model. Next is the expanded notation. expanded notation, and hopefully I have room for it. It's really hard for me to write small. 3,000. Actually, I'm going to move it over here. 3,822 divided by 7. 3,000 does not, I can't take, if I had 3 $1,000 bills, I couldn't put them into groups of 7. So I'm going to go all the way to the hundreds and make them 3,800 would be 500. 500 multiplied by 7 is 3,500. When I subtract that, I have 322 remaining. Again, I can't make groups of hundreds, but I can make groups of 10. I can make 4 groups of 10, which is 40. 40 groups of 7 are 280. When I subtract, I have 42 left. 42 can be broken into 6 groups of 7, which is 42 with 0 remaining. When I add, oh, that was terrible. I'm going to undo that one. When I add these together, I get 500. Hopefully I have room. 46. So that's the expanded notation method you might remember using in the past. Finally, the digit by digit method, also called the standard algorithm. Your parents should be excited about this. This is the one that they are probably most familiar with, and that I'm going to ask that you work toward as being a more efficient method. So 3,822 divided by 7. First, I divide. Can I divide 3 by 7? I can't. What I like to do is put a little X there for now until I get better at it. So, and then I just move over and go 38 because we're going to start from the greatest, take out as many as we can first, so the greatest place values. 3,038 divided by 7. I think there's 5 7s and 38. After I divide, I multiply. 5 multiplied by 7 is 35. After I multiply, so I took out 5 groups of 7. I had to multiply 5 by 7 to say 5 groups of 7 is 35. Now I'm going to subtract to see how many I didn't take out yet. Oops, that's a pretty good line there, Mr. Springer. I get 3 left. Yep, can't take another group of 7 out of 3. The next step is that was comparing. Compare to say, could I have taken more out? Nope, I estimated right. Now I bring down. So I'm going to bring down my 2. And now my 3 is no longer 3, it's a 32. I have really 32 tens. And I start over again by dividing. How many 7s in 32? Well, there's 4 7s in 32, I believe. I have to multiply to see how much would 4 7s be. They would be 28. I subtract to see what's left. There would be 4 left. I compare to say, hey, can I bring more 7s down? or can I take out a group of 7? No, I can't. Then I bring down the next one. Bring down the 2. Now the 4 becomes a 40 and 2 ones. Oh, I know I repeat the process. I divide, there's 6 7s in 42, 6 groups, then I multiply. 6 groups of 7 are 42 that I took out. Now I subtract to see what's left, and 42 subtract 42 is nothing left. I can't, the program that's helping me do this is hiding part of this on me. So I need to figure out what I can do here. Okie dokie. Sorry about that. Well, when I subtract, I have 0 left. Compare, yes, 0 can't be broken into a group of 7. I have nothing left to bring down. I'm done. At this point, what I want you to do is take a close look at this, pause the video, and compare the 3 methods. So see what you see. What do you compare? What do you notice when you compare the 3 methods? Pause. Okay, you should be back with me. Something you should have noticed is in all 3 of them, we're starting from the greatest place value and working our way down. We're taking out the greatest amount we can first and working our way down. Each time we literally did divide 3,800 by 7 to get 500. Each time we did divide 322, but here it was really just as 32 by 7 to get 4 tens or 40. And finally, we divided 42 by 7 to get 6 each time. The reason this works is because of the great distributive property. And hopefully you remember I was talking about this distributive property. Work hard to really understand this property. It's like a magician. Division strategies involve finding the unknown factors that add up to a quotient. We build the final product with the greatest factor we can use, place by place. We find the greatest unknown factor, the 500, first, the greatest unknown one first. Then subtract so we can find the next known factor, 40, and then subtract so we can find the last known factor, 6. We know the strategy works because it is based on the distributive property of multiplication and addition. That moves all there. I got it to work. Now, hopefully that keeps working. So here shows it. Why does it all work together? Because the distributive property tells me that when I'm taking 7 multiplied by 500 plus multiplying it by 4D plus multiplying it by 6, it's the same as taking and adding the 500 plus 40 plus 6, or making it 546, then multiplying by 7. So now you should be able to do the first page. I believe it's page, it's dark in my house now, it's at night. 193. Make sure you write an equation on the blue line first. Remember, an equation uses a variable. So you will either write something like 28 divided by 4 equals x, or 4 multiplied by x equals 28. I'm going to scroll through the page kind of slowly so people can pause their video and then do the work on a piece of paper if they don't have their workbook home with them, their student activity book home with them. And I suggest doing them on paper where you have more room anyway. So you could pause the video and do this page now, and then come back to the video later when you're ready to move on. Okay, now let's talk through remainders and numbers 7 and 8. Working with remainders. The problem at the right might seem unfinished because look at here, it's not done. The leftover number at the bottom is called the remainder. We can write an answer like this: 567 R2. I like to put a period there when I abbreviate remainder, but I don't care. Just so you know, you can write the remainder after the quotient as a whole number 2. All right, so they did all this division. They said 4 does not divide by 8. 45 divided by 8 is 5. 5 multiplied by 8 is 40. 45 subtract 40 is 5. 5 is less than 8. So that can't be divided anymore. They brought down the 3. 53 divided by 8 they thought was 6. 6 multiplied by 8 is 48. 53 subtract 48 is 5 remaining. 5 cannot be broken into a group of 8. So they brought down the next digit, which was the 8. 58 divided by 8, they said that's 7. 7 groups of 8 is 56. 58 subtract 56, remainder 2, but they have nothing left to bring down. You might want to replay that a couple times if you're still not real strong with the division process. That's me talking through it again. So they have this question for us. Could there be a remainder of 9 for the problem? Why or why not? Pause the video and discuss that with somebody. Or just think about it really strong. Okay, I'm back. Now, definitely I would say is no, we cannot have a remainder of 9 because if the remainder was 9, I could have taken another group of 8 out. So I cannot have a remainder greater than my divisor. So what is the greatest possible remainder when dividing by 8? Pause the video and discuss. Welcome back. The greatest possible remainder when dividing by 8 is 7 because if I had 8 or greater, I could take another group of 8 out. You now should be able to complete this page. I suggest, it says here, use any division method. I hope you would try to use the digit by digit or standard method, as that's what I want you to work toward. I also suggest working on another piece of paper where you have more room. I like to turn the paper and put one of each of these digits in a column. It just gives me help. It just helps me keep it straight. I'm going to scroll through it slowly in case you don't have your student activity book at home and you need to pause the video to copy down the problems and then do it on your paper. So there you go, pause it on that. All right, the next part of lesson 1 is using mental math to check for reasonableness. They have this math situation where Miguel has 6 boxes to store 1,350 baseball cards. He divides and finds that each box will have 225 cards. Because he has a total of 1,350 cards, he needs to put them in equal groups of 6, so he knew to divide. To check that the answer is reasonable, he used estimation and mental math. Well, when we've done most estimation and mental math, we would round. Well, if I round 1,350 to 1,000, and divide by 6, that's not super easy. And it really doesn't even take me close because I'm not in the thousands anyway. So now really I want to do is look at my first division is going into the 1300s, is in hundreds, right? Well, if I round this to hundreds, it gives me 1400s divided by 6. Well, guess what? 14 doesn't divide evenly by 6. I want to use, in my hundreds, my multiples of 6. First, I'm going to take the multiple of 6, the first multiple of 6 less than 13, which is 12. And think of 1200s divided by 6. 1200s divided by 6. Well, there would be 2. 2 groups of 6 is 12. I have 0 left. And I'm going to stop doing this now because, like it says, I can do mental math. I know 1,200 divided by 6 is 200. 12 divided by 6 is 2 in the hundreds. Now, the next thing I'm going to use is the multiple greater than 13. The next multiple of 6 is 18. So I'm going to think of 1,350 as 1,800 divided by 6. And there are 3 6s in 18, so there are 300 6s in 1,800. I know my quotient should be between 200 and 300, and it is. And I kind of do know it should be a little bit closer to the 200 than to the 300, and it is. So that is how you check for reasonableness. You can replay this video over and over again to help you with what you do. All right. Again, they say solve using any method. I do prefer you use the digit by digit method, standard method. Then use mental math to check the solution. So you're going to round the dividend to the 2 multiples, one above and one below it, that divides easily. I'm going to slow that down so people can see the problems and pause the video to do work in their notebook if they don't have their book. And there's the rest of it. And now you should have enough information to complete that page. And that should complete lesson 1. Thank you.